In section D, we're going to deal with parallel lines. And so there is this theme of all these proofs that you're going to have to prove. And the only thing that they're going to add in section D are some things that are congruent because of parallel lines. The two things you're going to use on this worksheet that you're going to add to your tool belt are the alternate interior angles theorem. The way this worksheet works is it doesn't just call it the alternate interior angles theorem, it calls it alternate interior angles are congruent. I would accept either way. If you were to write alternate interior angles are congruent, I would accept that. I would also accept the alternate interior angles theorem because that is it comes from geometry. It's another reason as well. A theorem is something that has been proven and is accepted by mathematicians everywhere. The other thing that we will use is the corresponding angles are congruent or the corresponding angles theorem. I would accept either one as a reason why two angles are congruent. I think the hardest part for most of you will be, well, which one's which? How do I know which ones are which? And that is why I asked you to draw these two sketches. Because when two lines are parallel, in your sketch over here, let me just go to this one, this top one right here. In your sketch, when these two things are parallel and you have a transversal, the alternate interior angles are the ones on the inside corner of the Z or the N. So if I see this and it looks like a Z or a backwards N, the inside angles are congruent to each other. I'm going to put a single arc and a single arc. Those are the two angles that have to be congruent to each other because they're alternate interior angles. I'm going to put alternate interior angles. And they're congruent to each other. And that's not the only one. Those are the ones that are congruent to each other because of the blue line. There's another pair that's congruent to each other because of this red line. And so I could either use those two single arcs or I could use the double arc and the other double arc that are congruent to each other because of alternate interior angles. I want you to know that both pairs are congruent to each other. These single arcs are congruent to each other and the double arcs are congruent to each other by alternate interior angles. That is the first way you would see it. I like to think of this as the hourglass because it looks like an hourglass to me. I don't know if you know what an hourglass is because your generation probably doesn't ever remember seeing a little timer. Maybe you could think of it as the boggle timer. You guys ever play boggle and you have to turn the little timer over and then the sand goes through the hourglass? That's what I'm referring to. That's what it looks like to me. Those of you who've never played board games, you've probably never been bored. I don't know. The other type of angles you will use are something called the corresponding angles theorem. The corresponding angles are theorem. They look like the letter F, in my opinion. When I see two lines that are parallel, here's the sketch that we have. If this is parallel to this, or if this is parallel to this, I'm going to do both because I've seen is either one or the other or both on the worksheet. If these two are parallel to each other and there's a transversal that connects the two, these two are parallel, here's the transversal, the corresponding angles are congruent. They are the ones on the inside of the F. This single arc would be congruent to this single arc. Those are corresponding angles. When I say the F, I'm looking for these angles as a part of that F. And that is only for these two parallel lines. The single is parallel to the other single. The doubles are parallel to each other. So that means there's another pair of corresponding angles. This angle here, I'm going to put a double arc, is congruent to this double arc because their corresponding angles are congruent. And if you're looking for the F, I know this has a really ugly backwards F, but that's what it would look like for the double arc. In your proofs, if you see that, you know that they are congruent. You can add congruent marks because of the corresponding angles or because of the alternate interior angles. So those are just the two review things that we've learned in Math 1 that we're going to use during these proofs. And then, of course, now what they have us do in Section D is that we actually have to fix the errors. We're not just going to find the errors, we're going to fix them. That means we're going to change them from the wrong statement into a correct statement so that we can prove the things that are parallel. So I have chosen two examples for you. Those of you who have the 3D worksheet, you can do this directly on the 3D worksheet. It's behind 3C, obviously. And what we wrote down in 3.3a is 7 steps. We're going to follow the same 7 steps that we've been using to fill out these proofs as to reasons why we know things are true and not true and so on. So, number 3. The first statement that we always make. I'm pretty sure you know what we're going to do with the first statement. We should all be experts in this by now. Is whatever follows the given statement is what we copy down for our first statement. So what am I going to write down for number 1? Segment BE is parallel to segment CD. And segment AE is parallel to segment BD. That's what that means. And lastly, B is the midpoint of AC. Our first statement is always what follows the given statement. And I bet you know what your reason is. The reason is, say it out loud. Good job. In other words, the word given means this is what you're starting with. This is the information you begin with during this problem. And that basically sums up what we did for numbers 1 and 2 of our steps. Number 3 says we add congruent marks or any given information to our picture. So the very first thing that it has is it says BE is parallel to CD. That's not congruent. These two little lines mean parallel. BE is parallel to CD. Since this is your first bit of information, what I would do is I would draw a single arrow on both of those, BE and CD, BE, CD, so that I know, oh, those are parallel. That was given to me. That's your first piece of information. I just draw a 1 and a 1, parallel, parallel. Then I'm also given that AE is parallel to BD. Since that's my second piece of information, I usually will draw 2 arrows since they're parallel. It does not mean congruent. It just means parallel. So I know that these are parallel, and I know that these are parallel. And the last thing that was given to me is that B is a midpoint of AC. How do I write that? If this is exactly in the middle of these 2 points, if this is in the middle of these 2 points, do you know if any sides are going to be congruent to each other? What does that mean if this is the midpoint? I'm hoping you know that if this is exactly in the middle, that this side here has to be the same as this side here. So we're going to be able to actually add a congruent mark. We just have to make that as a statement in our proof. And probably we should start with that. I think that's what a good number to statement. What's congruent to what?
AB is congruent to BC.
Segment AB, I'm going to put the little bar on top, is congruent to segment BC. And we got to figure out a reason. Why do we know that these two pieces are congruent? It has something to do with this word.
Definition of
It's a midpoint. So when we're using that word's definition, we can say the definition of a midpoint. That gives you one side of your triangle is congruent to one side of your other triangle. Now what you need is a couple of angles. And I'm hoping you can start looking at some of these things that we wrote down here to find out which angles are congruent to each other. So if I see, let's see, this one is parallel to this one, and I know this angle here, angle A, has to be congruent to this angle, BDC. Why are those angles congruent to it? What type of angles are these? Wait, before I do that, let's write that down. Number 3, angle EAB, side vertex side, is congruent to angle DBC. And there's a reason why. Why is this angle congruent to this angle? Which of these postulates or theorems did we just write down? And I'm hoping you know what the reason is. Corresponding angles. You can either say theorem, or this worksheet says is congruent. I would accept either one. If you want to use the congruent symbol, you can. If you want to say the theorem, that is fine as well. Right now, if you're counting, we have an angle, we have a side, we have an angle and a side. We do not have another angle, and we have 5 postulates we're trying to pick from. In section 2, we learned these 5 postulates. And I have an angle and a side, so it's got to be one of these 3 things in the middle, I think. There's got to be some other angle here that's the same as another angle, and maybe you see it, because there's another set of corresponding angles here, because we have this parallel line and this parallel line. Let's do the double arcs. And let's write that as a subset of 3. I'm going to say angle EBA, side vertex side, is congruent to angle DCB. How do I know that these 2 things are congruent to each other? What are they? I'm hoping you know that those are corresponding angles as well. And so do I need to write a whole nother number 3 corresponding angles are congruent? No, you don't. You do not. You could put this as 4 if you wanted to, but since this is the same reason, I'm kind of keeping this all together like I did for the first statement. And now you have enough information to prove that triangle EBA is congruent to another triangle. It goes E, then B, then A. And in order to make it match E, then B, then A, we have to make sure that we match with the other triangle that is in matching order. The triangle must be triangle DCB. And then we write it up here as well, DCB. We have 5 postulates to pick from, but we have an angle touching a side touching an angle that's congruent to an angle touching a side touching an angle. I can already tell you what the reason why these 2 things are congruent to each other. It's because of angle side angle. Last example. Number 5. Number 5 says fix the errors. So there's a whole proof that somebody else did, but the person who did this proof made some mistakes. And we're going to have to find the mistakes that that other person made, and we're going to have to fix them. Given angle C is congruent to angle D. Angle C is congruent to angle D, given. Does the first statement and the first reason make sense to you? Is that what they're supposed to do? Then it's fine. Don't do anything with it. But what I would do with it is I would add it to your picture. I would go, okay, C is congruent to D. They've proven that. I'm okay with that. Put it in your picture. Number 2, angle A is congruent to angle B. The alternate interior angles are congruent. Are these congruent to each other? This one's a little bit harder to tell because you were taught alternate interior angles are only congruent if they are parallel. So is this parallel to this? It doesn't show that it's parallel. But because these two things are given, that these are congruent, are these alternate interior angles? Is that a Z? If they are, then that must mean that this is parallel to this. If they are parallel, then does that make the B and the A also congruent to each other? That is going to be a true statement. These are true and this is true. The only thing that I wish would have happened in between these two steps is I wish they would have had a step 2 here that said that DB was parallel to AC. If we were being really specific, it's because of the converse of the alternate interior angles theorem. I wish that that was there. But these are true, that's true. I'm going to put a double arc and a double arc in my picture. The next thing that it says, angle AEC is congruent to angle DEB because they're vertical angles. AEC, 1, 2, 3, is congruent to angle DEB. 1, 2, 3. This is the third piece of information, so I'm going to use 3 arcs to differentiate it. Are these congruent to each other by vertical angles? I agree. I think that they are. The last thing says triangle ACE is congruent to triangle BDE by angle, angle, angle congruency. Is first off, does ACE match up with BDE? Is that the matching order? Double, single, triple, double, single, triple? Yes. Is this one of your 5 choices? And is there any other way to be able to find that this is congruent to this? Is there a side that's the same? Is there any way to tell if any sides are the same? No. Is there any right angles or a hypotenuse and a leg? No. There is no way to prove that this triangle is congruent to this triangle with that given information. We are going to say that this is not provable. It's the only one that I have found in your worksheet that you're not going to be able to prove. So I'm going to stop your notes right there.